Dr. Edward Laniewski here at the Orthologic Biologic Institute Symposium in Chicago at McCormick Place, and we're talking about the cool use of cell-based therapies such as platelet-rich plasma with a leading researcher here from NC State. This is Dr. Lauren Schnabel. Did I say that?
Schnabel.
Schnabel.
Close. Yeah.
Dr. Lauren Schnabel. She is a tenured, she just got that, professor of equine orthopedics at North Carolina State University. And she had a wonderful paper about using platelet-rich plasma to help eradicate infections in horses. So why don't you tell us a little bit about how we can use cell therapy to help eradicate a terrible problem that occurs in orthopedics?
Yes, excellent, thank you. Yeah, so my laboratory, in collaboration with University of Pennsylvania and Dr. Scher's lab, has been looking at how we can fractionate down or specialize platelet-rich plasma into a very concentrated formulation that's effective against bacteria in synovial fluid. And the first step of that was figuring out how bacteria actually behave in synovial fluid. And they form these large aggregates together with an extracellular matrix, kind of like biofilms, but it makes it very hard for traditional antibiotics to work. And that's why we were seeking an alternative. And we know that platelets contain antimicrobial peptides, which are small and can kind of, we think, burrow through these biofilm-like aggregates and get to the bacteria, which is, we're still working a little bit on the mechanism, but have really nice data now to show that they are effective both in vitro and in vivo against these infections.
So most of our audience here doesn't have a PhD. So I'm going to put this in terms of Star Wars.
Sorry.
Let's think about that. Or Star Trek. And you have a force field, and that is called a biofilm, right?
Yes.
And that forms over like an implant that you would put into an
and it hides the bacteria.
And it hides the bacteria.
Yes, exactly.
And antibiotics can't get to it.
Correct.
But you went ahead and found out a way to get into that.
Yes.
And first, regular platelet-rich plasma might be a little bit too big to go through the force field. So you did the lysate that allowed it to penetrate through that biofilm, through that force field to get into the bacteria.
Yeah, and kill the bacteria. Yeah.
Awesome. Okay. And so then tell us what happened in your study.
Yeah, so in our study, so we did some in vitro background work in the lab, and then in vivo we infected joints and then treated them with either a traditional antibiotic alone or our lysate, PRP lysate, plus the antibiotics. And we had much better outcome measures all around. So on imaging, ultrasound, and radiology, but especially ultrasound, histology at end term, so looking at the composition of the cartilage for damage and the synovium for inflammation, and exudate from the bacteria. And then also, importantly, substantially dropped all our bacterial load. So there was very little to no bacteria in any of the treated horses, whereas the control horses all still had bacteria after treatment with traditional antibiotics.
And if I remember right, in one of your slides there, you said that all but one of the horses, the bacterial load was basically zero,
yes.
Eradicated.
Yeah, and in the one, it was just one quadrant of the joint which is where we do the inoculum, where we inject it, so it had like a little focal abscess there, And
just coming from my fellowship was in infected total joints, and so we always knew that even though we would wash it out numerous times, change the implant, there was always some bacteria there. But you say this has eradicated it, so it's totally eliminated it, which is phenomenal.
Yeah.
So with this great research that you have right here, where do you think this is going right now, and how this might help us and help animals? Where do you think it's going?
Yeah, no, excellent question. So we're very excited about it, but right now the formulation that we use is very labor intensive to make, and we know there's so much variability between donor horses, and it would be the same in people, I assume. So we use this pooled product, take out the immunoglobulins or anything that could be harmful. But what we're trying to do, what we are doing now, is isolating the peptides, the specific proteins that are responsible for the bactericidal action, so that we can synthesize those, which would be very applicable to human medicine as well, and be an off-the-shelf product ready to go. Because right now, the lysate's amazing, but it takes us literally like 3 months to make enough to treat, horses in the clinic. Yeah, and tested.
So this is just another example of how our own cells can be used to help keep us healthy
Yes.
and also treat a devastating disease. Because if you've ever had an infected toe joint, it is devastating, not only to you, but your family, everyone around you, the people that employed you. It's a devastating disease. And so, Lauren, thank you very much for spending that time with us and educating the public about what cells can do. And also, we're going to talk about what cells won't do at some point. So remember, these are your cells for your healing. Thank you very much, Lauren.
Thank you.